Okay, let's get started. Hello, everyone. So, first session this week. So, this will be the second last week for the semester. Time really flies, and I think to start with, I better remind everybody just about where we are in the course and what you can really expect yet to come for the course. So, before I move on to the announcement section, let's now review quickly about the semester calendar. Right? It definitely outlines what you're supposed to hand in, or something you should really supposed to get prepared. Let's take a look. All right, if you go to the semester calendar, okay. So today is November 24th. So we are now in the second last week over here. And you got your written test number 3. I will speak about, give you some hints, some tips later today. And so that'll be tomorrow, Thursday, and Friday, right? And also remember your lab number 5 was actually released on schedule on Tuesday, right? The lab number 5 will be due on the 6th of December. So please know that it will be difficult to really give you any extension, because after this, we need to really also get started with the grading by the TA. So we definitely have to set the deadline to be strict. So you really want to start as soon as possible, okay? And for next week, also your week number 11 lecture was released a little bit late, well, like yesterday. And that one there, I only got 1 hour. I'll speak about it a little bit. I do expect you to do some additional exercises to really help you get prepared eventually for the exam. And your last module for the lecture will be released on next week by the end of Monday. I'll try. And then that one there is going to cover one final topic called recursion. And that one there is going to connect you quite well, hopefully, to the next course in your degree sequence, which will be EECS2030, the data structure course. You definitely need a lot of recursion in that course. So I'm hoping to cover you all the basics and hopefully do some more advanced examples so you get ready for 2011 as well. And then we got your programming test number 3, and also I released the example questions and also the guide. And as you mentioned, what about the lab number 4 solution walkthrough? I will also do it for you, no problem. However, it will take me a little bit of time to actually record it. As I mentioned in your guide for the programming test number 3, I'll make the recording available by the end of the coming Monday. So you got at least another 2 or 3 days to actually go over the solution. And I also posted some simple test, like a simple example test. That one there is kind of based on your lecture example. At least you can get familiar with the formats. But I would say the best way to really get prepared for programming test 3, go over all the concept for the inheritance, make sure you're okay with them, and also to really also do the example, simple example test. And then as soon as I release the solution walkthrough by the end of Monday next week, you should really go over that. And ideally, you can also redo your lab number 4 as well. So, so that'll be my advice. Okay. All right, and our exam, I will talk about your exam. The date has been scheduled by the registrar office, right? I will try to release some guidance for you, either later next week around this time or early this week. But we got you definitely got more than a week to actually get prepared for the exam. But for your if you really want to get started already today, to really go over little by little every day, because the exam is going to cover everything. It is supposed to be comprehensive, so you may just want to get started right away, by going over all the lecture materials, right? Right, that's about where we are for the course. Right, let me just revisit the important items here. Your lecture week number 11, and that one there is just to complete about generics in Java, about how you can define the generic classes, and also to really compare and contrast generic classes versus general classes, like you have an array of objects. So what's really the differences between the two designs? You want to be very clear by the end of the lecture, okay? And there is certain programming exercise I put on at the end of the slides. So this programming exercise, just about completing the definitions for general book versus generic book. That's something I would expect you to do, right? If you got any trouble completing them, let me know. All right. Okay, and also number 3. So that would be some, even though it's optional, but I would say you really need to study that if you actually don't quite recall the details. So which is about how you can use array list and also hash table. So these are the two classes I presume maybe either you took your first year course from me or you actually took it from other instructor, but that's something we assume student would have learned from the first year. And for these two, there are some extra tutorial videos for you to actually look at and pay attention to about generics aspects for these two classes. All right, so that's about week number 11 lecture. Okay. And your lab number 5 will be due on December 6th, as I said, right? Plan your time well for that. Written test number 3 will happen tomorrow and Friday. And also your programming test 3 is going to happen next week, right? The final week for the semester. And for that one there, you want to go over the simple example test. All right. That's just to make sure you get familiar with the formats. Okay. And number 2, for your lab 4 solution walkthrough, I will try to record a video and make it available by the end of the coming Monday, right? But you shouldn't really wait for me for that. You should really go on to get prepared for other aspects for the programming test number 3. That's what you should do. All right. Any questions about the course in general before we dive into the technical contents for the lecture materials? Anyone? Any questions? Any doubts? Anything that's unclear to you about how things are going to happen? All right. Hearing none, let's now go over. The technical contents over here. All right. I only saw 2 questions from the Google Doc. Let's now go over them one by one. Okay. And the first one here, it's again, a little bit more like some observation and then question. Let's go over them to make sure you're also following your the thoughts of your fellow students. So methods, they are not abstract and they are not explicitly written in a parent class. They can cause a compilation problem if they are defined only in the subclasses and the call, right? So this is something we discussed in the case of the abstract classes. Let's say, for example, if you got class A over here, and also you got class B. Okay, let's say B extends from A. For the illustration purpose, let's say this class over here is actually abstract. Okay, and then let's say if you got, let's say, methods over here, let's say abstract N. Let's say is mutator. Okay, and then we got another one over here. Let's say we got, M is going to be defined by some code. Let's say we got another method called M2. All right, this is some newly defined methods in the subclass, in the child class. All right, let's now move on to actually illustrate what kind of problems can you have. Let's say if you got, for example, A, and then let's say objects is new. Let's say B over here. You should know very well, this is static type, that's dynamic type. And if I actually try to say obj dot, for example, M2, M, and also obj dot M2, right? For example, these 2 lines. You should know very well that one of them is going to cause a problem, the other one is not, all right? So all you got to check would be the static type for the context objects, which is A over here. Does A have M? Indeed, it does. So that's why this line is okay. On the other hand, you can see here, the static type for obj is actually A, but does A actually got M2? No, it does not, right? You can see M2 is not here. So that's why it's going to fail to compile. That's why the kind of problem you can expect to happen at the compilation time. Even though the dynamic type is actually B, but doesn't matter, right? Remember, for you to decide anything related to compilation, you only look at the static type only, right? And your fellow student was wondering about a specific case for the object class, okay? The object class is a parent of every class in Java. That's actually correct. It's correct understanding. When we declare some methods in our newly created classes, right? Let's now visualize that right away. So for example, you may have, let's say you have your object class over here, and every class that we create in our project, let's say class C over here, right? And you might define some new methods. Let's say we just say void, let's say CM, right? Method in C. And of course, you may put some code inside. Okay, so that's what we have. That inherits from the object class, and how will calling this method not cause a compilation error, right? So I think that's kind of the misunderstanding that come from your fellow students. Let's now use a very simple example to see you're really gonna have a problem, similar to what we just illustrated. So let's say if we have, let's say something like this. If we got objects over here, let's say O, okay, is new C. All right, and then I'm running out of space, but I'm gonna put it over here to continue. Okay, I'm gonna say O dot CM over here. All right. Let's now consider these two lines and explain why there would be a problem. This line here actually does not have a problem. This line is fine because C is a subclass of objects. So that means C can fulfill the expectation of objects. So this line is actually okay, right? The only thing you gotta remember is the object is implicitly the parent class for every class in Java, including those classes you declare in your projects or those classes that come from the Java library, either way. Okay, but what about this line over here? The same judging criterion is going to be applied because the static type for O is actually objects, right? And now, was CM defined in objects? No, it was not, right? So that's why it's not going to compile. That's why it's not going to compile, right? So you should also be very familiar about how to write down the written responses if the question will ask whether a particular line will actually compile, right? I'll repeat it many times in the lecture and also right now. So you want to make sure you can write it down. All right, any follow-up question to this? And that's about the first question I got, which nicely actually review about static type, and also dynamic type simply doesn't matter when you are only considering for compilation, right? Any follow-up question to this? Anybody? Okay, I'll pause for one more moment in case you're still thinking about it. Okay, let's see. From Marco, just to reconfirm, static type is the left-hand side and dynamic type is the right-hand side. Not necessarily. Not necessarily. When you declare this type over here, yes, this is static type, okay? When you talk about this expression over here, since we are using the new keyword, so the B over here is the dynamic type, right? It's not a static type, right? It's a new object expression. So this B over here is the dynamic type. And this part over here is the static type. You might have other scenario, for example, let's say this. If you got some object reference, let's say you got some reference variable v1 is assigned to v2, for example, right? In order to decide whether this assignment should really be valid, in that case, the v2 here is just a variable. It's not a new expression anymore. So you have to consider the static type of v2 and also the static type for v1. So these are the two scenarios. Whether the new expression is on the right-hand side or not, it depends. Does it make sense to you, Marco? Very good. Yeah, it's actually important, right? But you're right. You have to look at the right-hand side. Right-hand side can either be some expression like a reference variable, or it can be a new expression, right? In the case of reference variable, you got to consider its static type. In the case of new, you got to consider its dynamic type. And of course, the judging criteria will be consistent. You just have to know if one class can fulfill the expectation for the other, right? Very good. All right, let me now move on to the next question. The next question is not really like a technical, but I think it's worth addressing as well. So your fellow student was mainly asking about whether, given that there are so many YouTube videos on the web, and also there might be some many websites for you to look for maybe a partial solution to programming problem like a Stack Exchange, or maybe there's some website for called LeetCode. You can actually see many like an interview example questions. So now in that case, should you actually still read the book, right? Or any book I would recommend. I just want to address that quickly. That's part of my my points that I wanted to address in the wrap-up lecture anyway, but I can just mention them quickly. Okay, so I think one thing about YouTube video, I would say you want to choose the there are so many YouTube videos actually talk about like a different concept, like a programming or maybe theoretical concept, but some of them are good, maybe some of them are not so good. So, and some of them even give you false information, because nobody will do the quality check. So I would say if you really want to learn a new subject just by watching the YouTube videos, then you have to go do it at your own risk. Of course, in your case, I'm your instructor. In some way, I'm certified to teach. So that's why my YouTube video, you can assume all the information is correct. Of course, you can always challenge it as well, right? So you got to be careful about the quality, right? And also, if there's any false information that people might give, right? Nobody will actually check it, right? YouTube video, I wouldn't rely so much on learning a new subject on YouTube videos. You may just want to maybe go for some more, more authoritative sources. So I think the books is actually a very good source, because usually in order for you to publish a book, you have to pass some peer review and also pass the checks by the editor, especially if you're using some well-known publisher. So I would say books is quite a good way to learn about, especially if you're doing your undergrad degree in CS or maybe software engineering. I think there are many good books that actually definitely is reliable for you to actually read through. I will just mention about two books which I'll recommend anyway, usually to my students after finishing 2030. Okay. I'll make the slides available maybe after the final week once I talk about the wrap-up lecture. Okay, but I'll just show you the two slides over here. This is one book which is published a long time ago, but it's a very, very good book in order for you to really sharpen your skills about like a programming. Okay, funny enough, the book itself does not contain any Java code. It only contains something so-called pseudocode, meaning that only try to express the ideas in a syntax that's not directly relevant to any programming language. But it will be straightforward enough for you to actually translate whatever pseudocode it is in the book into maybe Java, to Python, to C# or to any language that you need to program. So I think that's a good thing about the book. It's very language independence book. So this book, I believe, is typically required by your 3101, the Introduction to Algorithm course in your third year. So what I usually advise to the students is maybe since eventually you will study this book right away, but maybe a little bit later, why don't you get it earlier? And this is what I would recommend you to do. The book actually talk about data structure and also algorithm. It's more like a shopping cart, of all the available algorithms and also data structure. You can just go over them one by one, okay? Like a section by section, chapter by chapter. And the first point is about understanding the mathematical analysis. You want to know exactly what's the logical rationale behind the pseudocode. That's also something I have emphasized in this course. Every time when I try to explain a piece of code to you, I also try to explain to you what's really the rationale and why the code is written in this way. Actually, that's very important. I think the book does a fantastic job in doing that. And you want to read the pseudocode to really understand the connection between the code and also the mathematical analysis. And then you will be able to translate into Java code. So this is the part that can really sharpen your programming skills. And then you want to write and pass JUnit test cases. That's why I try to also give you the responsibility to write your own JUnit test cases for every lab, and also sometimes for the programming test. So this will be a very good exercise for you to do, to dedicate to this book. The book is rather thick, so this is not like a short term, like a 1 month or 2 month exercise you can complete. I think to really complete this, if you can get it done by the end of the time you graduate, it's very good, right? So this will be something I suggest to you as a long-term investment of your time, right? It's up to you. Another one here is not so much about like a data structure or theoretical stuff. This one is actually very practical. It's also a very classic book, so-called design patterns. Okay, you can think about, especially for object-oriented software, design patterns is really a way to really organize a large number of classes. Especially there are certain problems which occur over and over in a software developer's career. So people actually summarize what the problems might be in different categories, and to say for this particular problem, this should be the best practice for you to adopt, right? And each best practice is so-called a design pattern. So this is also some book I'll recommend, right? Typically, it is required by your EECS2030, the software design course, usually, but only as an optional reference book. I believe the source code they provided in the book is C++, but since C++ is also object-oriented, you can definitely translate it into Java as well. So you can do the similar exercise if you wish. Try to understand each problem, each occurring scenario for the software developer that they have to solve, and then read the solution, even though that's not in Java, but it should be rather straightforward for you to translate into the Java source code. And then write and pass JUnit test cases, right? You can see it's a very consistent way of training yourself about how to not only just to implement, but also to test the correctness of your code. So these will be two books I really highly recommend if you want to go beyond this course and then do some extra endeavors, in your free time. It's definitely highly recommended. If you want to know a little bit more details about the book, feel free to speak to me during the office hour. All right. I think that's my quick responses to your fellow students' question. All right. So that's about the two Google Doc questions. Do you guys have any further questions to ask about the lecture materials? Anybody? There's only one small detail one small tip I want to give to you about written test number 3. But I can go there maybe at the end of today's session. I want to handle your general question first about lecture materials. Anybody? Anyone? Hearing none, let me now switch to this is the example question you got for your written test number 3. Maybe some of you haven't tried it yet, so I'll rather you try first. But the only one tip I want to give to you quickly about written test number 3, and also for your exam altogether. Okay, so you want to make sure when you answer the questions, either written questions or multiple choice question, you want to make sure you got your sketch paper ready. Okay, and then number 2, which is also hinted at the practice question itself, you want to draw the corresponding inheritance hierarchy diagram. Hierarchy diagram in order for you to actually answer the question, right? I'm going to solve the question itself right now because I should really give you the chance to really do it by yourself. But for example, you can see here, as soon as you see this particular decoration, right, we talk about it in the lecture. If I have class A, which extends B, as soon as I see this, I can say A actually extends B. That's what you should do right away, right? So if you got another one, let's say B extends C. B actually further extends another class. I'm running out of space, but I should really make one higher and the other one lower. Okay, and then and also you can see class C over here does not extend from any other class. And as soon as you see any method that's actually declared over here, you should really maybe annotate it. You can say for C, right beside C, I can put maybe some method over here, BM, just to remind myself. Later on, if I need to make certain method call on BM, I will be able to judge whether the static type will actually be consistent with the type over here, C. All right, so that's the tip I would like to offer to you. Okay, so you want to make sure you got some sketch paper, and also you are also familiar with how to translate from Java class declarations into inheritance hierarchy diagram, right? That's something I want you to make sure you're comfortable with before you write a test. All right, that's about everything I plan to say. Do you have any other question for me? Anyone? Okay, I'll pause for one more moment to see if you got any other question. If you don't, then I'll let you go earlier. Should the arrow be the other way around? No. If you say A extends B, right? A extends B. That's what we said, right? So whenever you got the arrow over here, the lower side should be the child class. The higher side should be the parent class. No, it should not be the other way around. And also B extends C, right? B extends C. And C does not extend anything. So that's why C would just be by itself. Yeah, be careful. It's rather basic, but I'm glad you asked to clarify. Okay, yes, if you actually want to go over some questions about the practice test during the office hour, you're more than welcome to. Yeah, so just in the session, I'll rather give you guys some opportunity to try by yourself, right? And I believe for your practice test, for written test number 3, I also gave you some example answer, like a standard answer. You can also check against. But if you got any doubts, you can still speak to me today. Don't forget, since yesterday's office hour was canceled, so today I'm extending it. So that'll be from 2:30 to 4. Okay, just make sure you drop by. All right, guys, final call for any question you might have. And also for your information, I think our exam is actually, luckily, our exam is not immediately after the term ends. So you definitely got some time to really digest and also to go over everything for your exam. That will be to your advantage. I will soon get in touch with everybody just to do a quick survey about which day or which times you actually prefer to do some maybe review session, more like a Q&A. So maybe I can just let you ask me any questions related to your lecture materials or other stuff related to the exam. I'll do that. So you can expect some email from me soon. Okay, that's about the exam. Okay, I'll pause for one more moment. Any other marks coming out soon? Yes. I will. I think for your lab number 2 and also lab number 3, hopefully the TA can finish them by the end of next week. I'm hoping. Okay. And then your written test number 3, that's gonna happen Thursday and Friday. So I'll release it by the end of the coming Tuesday. Usually I try to look at the written test a little bit after it's finished before I release it. Yeah, for sure. So the idea would be by the day of your exam, you should really get everything except for the exam. That should be clear to you. Okay. I know there's another deadline that's approaching. I forgot which day it is. I think there's another deadline for you to actually still drop the course and then maybe leave a W on your transcript. I think there's another such deadline. I'll try to give you maybe at least some more before the deadline. But everything will still be about the coordination with the TA, which will take some time. They are themselves also students, right? I'll
Professor,
try.
I had a question.
Yes, go ahead.
Yeah, so can I please see the notes for the week 10? Just the starting notes, or should I share my screen if you want?
Yeah, sure. I can go there. You mean the iPad notes for week number 10?
Yes.
Sure. Give me a moment. Week number 10?
Yeah.
Okay. Which page?
Just the first one.
This one here. Sure. Go ahead.
Yeah. So over here you said that when we have the get area method, so for that I just had an alternate solution, and I was wondering why we can't do that. So when you said psi.getArea at the bottom of the page, yeah. So why can't we just write? We can just write an if statement and say instance of and use the get area method in the rectangle and triangle class.
Okay, I see what you mean. Give me a moment. Let me set it up, and then we can talk about it. Yeah, bear with me. Let me set it up.
Yeah, no problem.
Okay, let me see. We should really go to interface abstract classes, which is over here. Okay. Oh, actually, I should copy the whole thing. Okay, good. Okay, let's say we got this over here. All right. Let's say the alternative design you have, let me just make sure I understood you correctly. So we don't actually have the get area over here. Is that correct? We don't.
Yeah.
Okay, good. Okay, that's good. Let's say the following. Okay, so we are really talking about polymorphic collection. Okay, so let's say we are now trying to do, let's say, a polygon. So polygon over here, let's say PS for polygons. And of course, you can initialize the array to a certain size. I'm going to omit the details right now. Okay. And then let's say we are trying to go, the reason that you really, the very intention about having a polymorphic collection or array is that you can really go over the array, actually elements one by one using a loop. Okay, so you can say for, let's say integer I 0, I strictly less than, let's say number of polygons, let's assume we got such a counter, and also I++. Okay. And what you were asking was, what if we use the instance of checks? Let's say I can say if maybe PS at index I. Let me just use one of them so that will illustrate the point. Instance of, let's say rectangle. Let's say rectangle over here, and then over here I can say PS at index I dot get area over here. Is that what you were suggesting?
Yes, exactly.
Okay, very good. Okay. Very good question here. I think it's also nice for us to revisit this example quickly. Okay.
Because I actually did it in the lab and I was wondering if I got it wrong.
Oh, okay. Okay. So this one here, I can tell you it's not going to compile. First of all, do you know why?
No, I'm not so sure. Because it's static type?
Yeah. So
yeah, okay.
So PS at index I, what's its static type?
Polygon.
Yes, corresponding to the decoration over here. The static type is polygon. And now, is get area declared in polygon in your design? No, it's not.
Yeah.
Right? So that's why it's not going to compile. The only way you can get around is by using a typecast. That's the only way. So for example, you might do things like, maybe I would say if there's instance of, so I can say PS index I can try to cast that into rectangle. I'll say rec over here. And then after that, you can actually say, I'm just using anonymous cast, dot get area. So this will be okay.
Yeah, this is what I did in my lab. So
okay, sure. Yeah. But yeah, it's programmatically it's gonna work. However, it's not a good design because that means you actually need to do some extra check about and do the cast. You could have got around with that by just including the get area in the polygon. You're somehow making your code unnecessarily complicated by introducing the need to actually do typecasting. So that's the main point.
Oh, right. Okay. Okay.
But it's not wrong. I'm just saying it's not ideal.
It's going to work though, right?
It's going well, hopefully pass all the test cases. I'm just saying, yeah. So there's nothing wrong programmatically with this because at least you know how to do a cast. I'm trying to say from the design point of view, it's not good because that will force you to do typecasting in many scenarios.
Okay. Okay. I understand.
Good. Very good.
Okay.
Yeah, we need a cast exactly over here. All right. And okay, another tip, yeah, sure. Another tip for you is in your example question for written test number 3, right? I gave you about 6 or 7, but it's mainly about these lines of code. with respect to this particular inheritance hierarchy. I think it definitely gives you some idea about what might appear in the written test, and also a similar style of test will also be also appearing in your exam. So here I only talk about like having some new dynamic type, and also about some reference variable reassignments, and also about calling methods. These are definitely worth talking about in the lecture. You may also want to review about how typecasting should be done, and also how the instance of check should be done as well, right? So that's why you should want to review all the relevant parts for the coverage, not just the one I gave you the example questions on, right? Just make sure you don't misunderstood my intention. Right. All right, any other questions related to lecture or written test? Definitely you can ask. I don't know exactly how many questions there will be. I'm still making the question, so I cannot really tell you. But I think you got 30 minutes, right? That's the same as last time. All right, any more questions before I call it a day? I still got my office hour today, 2:30 to 4. Feel free to come if you feel more comfortable speaking to me in person. That's fine too. All right, hearing none. Thank you for coming, and I'm gonna end the meeting now. But if you got any questions, feel free to get in touch with me. All right, you guys take care.